Okay, so in this video, we're going to create some objects of type grad student, and we're going to take a look at how inheritance and polymorphism work together. So this is our driver program that we were using, and instead of having these individual named students in my driver program, I'm actually going to create a student array. I'll just call it the students, and it's going to hold 5 students. So instead of creating student S1, I'm just going to have that be a student stored in the students at position 0 and the students at position 1 and the students at position 2. And then when I enroll, I'm going to enroll the students at position 0 and the students at position 1 and the students at position 2. So just to remind you how this class was working, if I run this class here, I created some students, I enrolled them in my course. Oops. Missing a parentheses. Let's move this up. And then I print the roster. So recall that the roster prints the underlying toString method of the student class, right? So the toString method in course. The toString method in course just prints the name and the number of rolled and the spots filled, but the, print roster method sorts the students by ID and then goes through the array list, and for each student it puts that student inside a print line, which if you don't directly invoke toString will be invoked behind the scenes if it's inside a print line. So this is the same thing as saying this, right? It's just Java gives us this nice little shortcut since printing the text representation is something we do very frequently. So that's what the print roster method does. So let's now go back and let's say, okay, well, I have some just general students in my class in this array that I'm creating of student data, but what if I also had some grad students? So if I wanted to just create a grad student object like this, I'll call it G1, I could do that, and I could send in, Greg grad with the ID 1672, and let's say the thesis topic is popular culture, I don't know. Okay, and I could create a second grad student, G2, that does not have a thesis topic defined yet, by calling my overloaded constructor, and I'll name this one, let's see, UMA uncertain. And for this one, I just send in 3 parameters to the constructor, and UMA uncertain will then invoke this constructor here, which will invoke this constructor here, which uses our undefined topic constant as the thesis topic. So this would be one way to go ahead and create students. Now, a grad student, remember, is a student. So that means that any place that I expect a student object, I can also give that place of code a grad student object, because a grad student is a student. So what I can do is I can say, okay, well, I'm going to want to put these 2 new students inside my array. So the students at position 3, hey, you know what that's going to get? It's going to get G1. No compiler error. The type of the students at position 3 is a student, and the type of grad student is grad student, but a grad student is a student, so this is okay. And actually, we could even define this here as student. That would be okay too, because this is a child class of this. So it's totally okay to declare the object of something as something higher on the inheritance tree, like student, and then to create or instantiate the type as something lower on the inheritance tree, like grad student. Okay? It's important to remember that Java only knows, the Java compiler, only knows the declared type of something. So if I declare, so let's take a look at this example here where I declare G1 as a declared type student. Remember, that's this part here, declared. It's a declared type student. I create it as a grad student, but I declare it as a student. The compiler only knows that declared type. So if I were to try to say system.out.println g1.getThesis, I'm going to get a compiler error saying getThesis is undefined for type student because the compiler only knows the declared type. So that's really important. If I try to have the same statement for G2, it's totally allowed. Oops. Right. Did I spell it right? GetThesis topic. Sorry, that's what it's called. That's totally allowed because G2 is declared type grad student. So the compiler, when it's checking to see if that method exists, it checks in the declared class. Okay, so that's really important to know. So if I were to change G2 to be a declared type student, I would now get a compiler error here. Okay, so this gives us a compiler error because the declared type of G1 is, oops, sorry, is student. Okay, so the compiler time, at compile time, the compiler only knows the declared type. But what polymorphism allows us is that at runtime, the Java runtime engine is a lot smarter than the compiler, and it can figure out the actual type. So at runtime, the Java virtual machine, the JVM, says, okay, I know G2 was declared as a grad student, but what type is it really? And for G2, it's really a grad student. But it's also going to say, okay, I know G1 was declared as a student, but what type is it really? And what type it really is, the actual type, is grad student. So the declared type is student, the actual type is grad student. Now that doesn't allow us to do this line of code. We still can't do this because we can't get it to compile. But what it does allow us to do is it allows us to take advantage of the fact that we can figure out what the actual type of an object is, and then invoke that most specific version of an overridden method. So let me show you an example of this. So here we are adding our students to our course. Well, let's also enroll some of our grad students. So let's enroll grad student 1 and grad student 2. Now, first of all, why is this allowed? Well, the enroll student method takes what as a parameter? It takes a student. And what did I just send in as a parameter? I sent in a grad student. But that's allowed, right? Because a grad student is a student. So my enroll student method is expecting a student. Well, I'm giving them a student. I'm just giving them a more specific type of student, but that's allowed. Okay, so anywhere that you have something that's expecting something higher on the chain, you can always give it something lower on the chain. So you can always give it something more specific. Can't go the other way around, but you can always give it something more specific. Okay, so now I have added my 2 grad students to the course. So let's rerun this and see what happens when we print the roster. So now we print the roster. You'll notice that it used the compare to method defined in student to sort the objects, right? Because remember that compare to method was inherited into grad student. But you'll see that for our grad students, their thesis topic is printed out. Well, how did that happen? Well, let's go back to our print roster method. So print roster invoked the toString of each student, right? So the print roster invokes the toString method of the whatever student is in the array list at that position. But what polymorphism allows us to do is when we actually run this code, the JVM, the Java virtual machine, will say, okay, I know that you're telling me this is a student, but I'm going to actually find out what the actual real type of this object is, and then I'm going to call the toString method that makes sense for that object, starting lowest on the chain, looking for the most specific one. So if S really is a student, like these first 3 objects that we put into the array list, then it's going to invoke the toString method in student. But for the last 2 elements in the array list, the actual type is grad student. So it's going to go first to the grad student class and say, oh, is there a more specific toString version that I should invoke? And there is, and so that's the one that gets invoked. So polymorphism means that at runtime, the JVM figures out the actual type of an object, not the declared type, but the actual type, and that it invokes the most specific version of that method for that actual type. So if we had not overridden toString in grad student, the JVM would have said, okay, is there a more specific toString in grad student? And if there wasn't, then it would have just gone one up the chain to student and gotten the toString from there. But since there is a more specific version in toString, that's the one that gets invoked. So this is really powerful, right? Because in our print roster method, we don't have to worry about, oh, is this a grad student? Because if it is, I want to print the thesis. And if it's a student, I just want to print the name and the ID. We don't have to worry about any of that. We just say, hey, print the toString, invoke the toString method, and the JVM at runtime will pick the right one. It'll pick the one we think it should pick, right? The one that's associated with the actual type of the object. So again, really powerful stuff because it allows us to override methods in child classes, giving the enhanced version that we want or the modified version of that method that we want. And then at runtime, it's almost like magic, right? The Java will just figure out the right version for us. So the basic rule of thumb is at compile time, the method has to exist, right? So because there is a toString method in student and there's a toString method in grad student, I'm allowed to do this. I'm sorry, because there is a toString method in student, I'm allowed to do this. There is not a get thesis topic method in student, so I am not allowed to do this. So at compile time, the method must exist in the class of the declared type. So let me say that again. At compile time, the method must exist in the class of the declared type. So that's the only way you can get it to compile. But at runtime, what actually gets invoked, the version of the method that actually gets invoked, is the most specific one based on the actual type of the object, not the declared type, the actual type. Okay? So again, this is a really important idea in Java, and as we start looking at some more complex data structures other than just the array list class, we're going to use this idea a lot. So make sure that this idea is clear to you and you understand what it means. And again, those two rules of thumb about what has to be there at compile time and then what actually happens at runtime. Now let's just look at one more example of this. So here I had added our two, let me add the other student into just the students array. So let's say we wanted to, separate from our class, let's say we just wanted to go through our array and we want to print out just the thesis topics of just the grad students in our array. Okay, so let's say we loaded a bunch of student data in from somewhere. We have this array of all our students, and then we want to go through all those students and only print out the thesis topic of the grad students. We basically just want a list of all thesis topics for all grad students. Okay, but in our array, we might have some students, might have some grad students, might have some undergrads, etc. So to do that, we would do this. So we're going to cycle through our array. Sorry, my computer is a little jumpy. I did not want this to be happening. All right, let me put this on pause. Sorry about that. Okay, so we're going to cycle through the array, and at the only thing the compiler knows is that the array contains students. So I can go through my array and I can pick out the student at each position. And this is allowed by the compiler because when I declared my student array, I declared it of type student array. So all the compiler knows is that this thing holds students. The compiler has no way of knowing if the actual type of objects in that array are more specific. It doesn't know, and it doesn't care. All it knows and cares is, hey, you declared this to hold students, so all I know is that it holds students. Okay, you can kind of think about the compiler as like, it's wearing blinders. All it sees is the declared type. That's it. It's all it knows, all it sees. Okay. So what we want to do now is what we want to say is, okay, well, I'm going to pull the student out of this array. And then what I want to do is I want to print the thesis topic. But I can't do that because if it's just a regular student, there is no get thesis topic method. So what I want to do is I want a way to find out what the actual type is of this object I've pulled out of my array, and Java gives us an operator to do that. It's called the instance of operator. So what I can do is I can say if st instance of grad student, and what this does is it returns a Boolean. If the runtime actual type of st is grad student, this will return true. And if it's not, then this will return false. So this is going to be a test at runtime that's going to determine the actual type. So instance of checks the actual type at runtime. Okay. I should note also that if I had put in student here and the actual type of st was a grad student, this would still return true because a grad student is a student, right? So if I were to put any object instance of object, that's always going to return true, right? Because object sits at the very top of our inheritance chain, so everything is an instance of object, just much more specific kinds of objects. Okay, but that's just a little aside. So let's go back to grad student. So, okay, so now why isn't this working? I've checked to make sure that st is an instance of grad student, and only if it is have I said to get the thesis topic out. Well, remember that the compiler is like, just knows exactly what you tell it, and still all it knows is that that declared type of st is student. So even though I can see as a human that I'm inside this if statement and I'm only ever going to get in here if st is actually a grad student, compiler doesn't know that. All it looks at is one statement at a time, and when it looks at this statement in isolation, meaning it has no idea that it's inside an if block that has confirmed a different type, all it knows is st is a student and there is no get thesis topic method inside a student. So what I actually have to do is I have to first check to see if it is a grad student, and then I'm going to actually cast it to be that. So casting is a way that you can change the type of one object to another. And I'm going to now create a local variable gs with the declared type of grad student, and that's the object that I'm going to invoke the get thesis topic on. Now this is allowed because what does the compiler know about GS? It knows the declared type, grad student. So hey, that's great. You're giving me a grad student object, I can invoke get thesis topic. Now technically these lines would work without our if statement, right? So if I comment out the if statement, these lines will work just fine. But this is really dangerous to do because what am I actually going to do here? I might take a student object that isn't really a grad student and cast it to grad student, and that's going to throw an exception and crash my program. So even though this is allowed from a compile time standpoint, it's not good practice and you don't want to do it. If you're ever going to cast an object from one type to another, you always want to make sure that it actually is an instance of that type that you're casting to. Okay, so these two things go together, the instance of and the cast. You should always use them as a pair. So now if I run this program, I'll get my course printout, and then at the end I just have a list of it cycled through my array of 5 students. For the first 3 students, they weren't grad students, so it just skipped them. And then for students, the 4th and 5th student, they were grad students, so it casted it to be a grad student and then printed out the thesis topic. Okay? So hopefully this is some good examples of inheritance and polymorphism. Again, these are really important topics that we're going to build on all semester. And hopefully you have some understanding coming into this course about these topics, and this served as a good review about them. But if you're still a little shaky on these topics, please post questions to the forum because, again, we're going to build off these topics the entire semester. So it's important to make sure that we all start with a strong understanding of these ideas at the beginning so that we can all move forward and build on them for the semester.